Now, why don't we just always use the substitution method to solve a system of linear equations with two variables? Why do we need another method, this elimination method? Well, let's suppose we have a system that looks like this. 3x plus 7y equals 4, 2x minus 7y equals 6. All of the variables here have coefficients. And all of them have kind of awkward coefficients, right? We couldn't divide both sides of either equation by 2, or by 3, or by 7, without having to deal with fractions. And while that's not the worst thing that could possibly happen to us, we'd like there to be a way that we could solve this system with a minimum of algebraic manipulation. So let's pay careful attention to what these equations say. The first equation says one quantity equals another quantity. The second equation says a third quantity equals a fourth quantity. Now there's a thing that we know about equality, and that is if two things are equal and we add the same value to them, they stay equal. We usually use this property to justify things like if x minus 3 equals 4, we can add the number 3 on both sides, and we get x equals 7. But there's a key fact that we haven't really used very much yet, and that is that we don't need to add exactly the same object. We can add just things that are equal to each other. So if we had like x minus 3 equals 5 halves, we could think we're adding 3 over here. We're adding 6 halves over here, because 3 and 6 halves are equal to each other. We'll get x is 11 halves. In the same way, if we know that 3x plus 7y equals 4, and 2x minus 7y equals 6, we can put these together by adding the two left sides and saying that that's equal to the sum of the two right sides. All right, let's see how this works. We're going to add the two left sides and say that that's the same sum as the sum of the two right sides. Now, why does this do us good? Let's combine like terms here. Right, we've got 3x plus 2x is 5x. And importantly, we have positive 7y plus negative 7y is 0y. Right, this term doesn't actually do anything. So we get just 5x equals 10. Dividing both sides by 5, we get x equals 2. And now we can go back to whichever of the two equations we like better to find y. I like this first one very slightly better. 3 times 2 plus 7y equals 4. 3 times 2 is 6. Subtract 6 on both sides, divide both sides by 7, and we get y is negative 2/7. That's a fraction. It's a perfectly good number. So our solution is x is 2, y is negative 2/7. Now that seems a little bit weird. I don't blame you if you doubt me. Let's check in the other equation. Right, the other equation is 2x minus 7y equals 6. So we want to check 2 times 2 minus 7 times negative 2/7. Well, that'll be 4 -7 times -2/7 is +2, and that does indeed work out to 6. This step looks kind of messy, and we usually don't write out this step in exactly this way. Let me show you another example that will show you the way that we normally write out this step. So let's suppose we have the system 5x minus 2y equals 2. -5x minus 4y equals -26. We write a horizontal line under the system as if we were doing some sort of arithmetic operation. And we realize that we're going to be combining like terms after we add the left-hand sides, after we add the right-hand sides. So we write the like terms above one another, and we just add. 5x plus -5x, that's 0x. -2y plus -4y, that's -6y. +2 plus -26, that's -24. That's the same thing that we would get if we'd copied these out and added them together and combined like terms. But we can go around that step. And now we have our equation in one variable, -6y equals -24, right? 0x. That was eliminated. This is the elimination method. Divide both sides by -6, and we get y equals positive or -4. Right, positive. And now again, we can go back to either equation to find x. I'm going to choose this one. 5x minus 8 equals 2. Add 8 on both sides. 5x equals 10. Divide both sides by 5, and we get x equals 2. Let's make sure that worked right by checking in the other equation. -5 times 2 minus 4 times 4. That'll be -10 minus 16, which will indeed be -26. So our solution, 2, x was 2, and y was 4. All right, I'm going to have you try one of these. Again, just adding together the left-hand sides, adding together the right-hand sides. Solve the system. 4x minus 3y equals -7. 8x plus 3y equals -5. Pause the video and try this now. Alright, so we add together the left-hand sides. 4x plus 8x is 12x. -3y plus +3y is 0y. -7 plus -5 is -12. 0y is eliminated. We'll divide both sides by 12, and we get x equals -1. I'll use this first equation to find y. I'll have 4 times -1 minus 3y equals -7. -4 minus 3y equals -7. Add 4 on both sides. -3y equals -7 plus +4 is -3. Divide both sides by -3, and we get y equals +1. Our solution is x is -1, y is +1.